All right, so this first problem we're going to do is going to be a arc length problem. I'm going to pretend we're I don't know, a civil engineer, and we got to design a roadway, and we need a quick estimate on the amount of roadway we need for an exit ramp. So the highway is buzzing along here like this. And then there's an exit ramp that's actually going to come off the side and come around in a really nice arc, but then it's going to head off that direction. There it goes. So the exit ramp, your car is driving down the road. Let's draw a little car on there. You got a little car who's driving down the road, and he's going that direction, and he's going to exit off the ramp. He's going to go around this cloverleaf type thing, and then right about here, it starts going straight. So we're actually looking at something that looks like this as far as a arc length. Now, some things that we know about this exit ramp as we sort of designed it out, the radius of this thing is actually going to be 50 feet. And this angle, the angle that we are kind of working at here, we're going to set that at this angle right here. We're going to set that at 210 degrees. Okay, so all of that said, there's our nice little picture of the car going around this exit ramp as you'd be looking down on a map. Okay, to solve this thing, what we're actually going to be needing to do is we got to pull back some math. We need that circumference of a circle equation. Remember, that was the circumference is equal to 2 pi times r, where r is the radius and c is the circumference. But that, of course, assumes that we want to go all the way around a circle, which we don't really want to do here. We want to only go part way around. We want to go 210 degrees around the circle. So what we had said was we could actually go part way and call it the arc is equal to the part of the circumference. The arc was equal to not 2 pi, because remember, that's the radian all the way around, but the angle of that arc, just the partial angle that we need. So I'm going to, for the moment, I'm just going to call that theta times r. So we don't want to go 2 pi. We want to go something less than 2 pi. And in this case, we want to go 210 degrees, but we have to do the 210 degrees. Let's see if I can grab those and make them a little better. There we go. Okay, slide those up. We want to take that 210 degrees as a radian measure, not a degree measure. So here we go. Let's go ahead and work out this problem and see if we can't figure it out. The arc length, the length of the road required, is going to be, I'm going to say 210 degrees. Now, I need my conversion right now. I'm doing this part right here. The conversion to make it a radian measure. That was going to be, so 210 times pi over 180. Okay, you got that whole piece. That's your radian angle right there, and then times your radius, which is 50. Okay, you go ahead and take that whole thing and you plug it into a calculator, and I'm going to get an awesome answer of, bum ba da da, are you ready for this? 183.2 feet. 183.2 feet. Now I'm thinking to myself, is that a good answer? Well, I suppose if the radius of this thing, if the radius of this thing is only 50, then 183 might make sense because clearly the path on the outside is bigger than the radius. But then I want to say, wait a second, maybe I should just check what would the full circle be. Remember, that would be using this guy here, 2 pi times r. So what would the full circumference be? The full circumference, 2 pi times r, that one is actually equal to 314 feet. Well, if I was going all the way around the circle, sure, 314 feet might work well. But this isn't, so this is just part way. And yeah, so I guess that'd be about right, 183 feet, that sounds pretty good. All right, so anyway, there you go. That's a quick review of how to do arc length. I hope you enjoyed the question.